So for this problem, what we have to find is the magnitude of force T, which is of those two tensions that are pulling it upwards. So first what we want to do is, since this is an equilibrium, we know that the acceleration is zero. As we see, the sum of all the forces will equal zero. So all the forces present here in this is the mass times the gravity plus the external force, which is that little f, minus the t cosine of 30 minus t cosine of 30. So the two t's on the top equals zero. We start plugging in the numbers. There's 6.0 kilograms times 10, which is gravity, plus 410, which is the external force, minus 2t cosine of 30 equals 0. So 2t cosine of 30 equals 60 plus 410, which equals 470. Now I want to isolate it and leave the t to one side, so we divide it by 2 cosine of 30, and we do 470 divided by 2 cosine of 30. T equals 470 divided by 1.732, which gives us the answer that T is 2.71 newtons in tension. So that means that each of the T's is approximately 271 newtons.